There are three advanced tasks that many of us, even at the advanced level of statistics, for example, when it comes to engineering statistics, we know, we hear about statistics. So that was the reason I have put these three tasks. So in that way, you get a better understanding of what statistics is about. So when we talk about data analytics in this class or even in other classes, you can distinguish them better. Okay, the first one that you see is hypothesis testing. Very famous thing in statistics that many people know statistics as a tool to test hypotheses, something that is not the first goal of data analytician. But when it comes to uh, statisticians are known for testing hypotheses, creating them, defining them, and after that, based on data, they test them. That's the reason you see even when we talk about the statistics and even about the main task that is hypothesis testing, we are talking about data. But it is not called data analytics. It is a statistics, although it is based on data, absolutely on data, 100% data, but data with math, with probability, with all the things just to do that. It is called a statistics. Here we have an example. Statisticians working, for example, in clinical settings often use hypothesis tests. In every sector, hypothesis tests are being performed to determine if a new drug causes improved outcomes in patients. So, what is the hypothesis? The hypothesis is this: the drug causes improved outcomes in patient. It is the hypothesis. So, based on statistical techniques and the data that they have, because the statistics is based on data, and that's the reason these two things are mostly many times confused, because they both statistics and data analytics based on data. So it is hypothesis testing, and now here we have the application, the practice in healthcare. They want to test if a drug has positive effects on patients. For example, a biostatistician may administer a blood pressure drug to 30 patients. Okay, you remember, my friends? Here we had it. Collecting data, analyzing data, interpreting data, and presenting data. And so here you see a biostatistician administer a blood pressure drug to 30 patients for 1 month, and then administer a second blood pressure drug to the same 30 patients for another month. All this design, all the things that we need to do it for 30 patients. Why not 40 patients? Why not 300 patients? Why just two categories? Why for 1 month? Why they should be the same? All the things are the field in control of statistics. While in the 4 years that you are in the department, in our department, we are not discussing this type of things because they are statistics. We are trained to use these techniques, the result of these techniques, or use software to do such things and get the results for data analytics projects. Then they may perform a paired sample t-test. Again, in statistics, we have many tests. And here it's one of the most famous ones, t-test, to determine if there is a statistically significant difference in blood pressure reduction between two drugs. If there is a significant difference, and again, the definition of significant difference is very determined, very specified in statistics. Because when they said that there is a significant difference, it means that it is a reliable difference. For example, the acceptance of, for example, when it comes and says that yes, there is significant difference, we want high reliability for that. For example, it should assure us, for example, for 95%, there is a significant difference in blood pressure reduction between these two drugs. Statistics is about such things, my friend. So you see here, you don't see decision making, you don't see insight regarding a business decision. Okay, but here it is just about a statistical task to determine if there is a significant difference between this and that. You may ask, okay, how a data analytics can use this? A data analytics use this at that way, because there are many data analyticians, they are very good with the statistics, and that's a fact that I always recommend to our students that learn statistics, because statistics is one of the most powerful tools we use in data analytics. Try not to be only a customer of statisticians to get the results, because we have, when they want to do something, for example, data analyticians, they give it to some statisticians to run the model, to do all those things for them and give them the results, if there is difference or there is not. Okay, so data analytician, what they do, for example, they give the data, the analysis, and after that they said that yes, the hypothesis is approved. When it is approved, now it is decision making. That is, for example, if it is approved and when with a considerable difference, a statistically significant difference, they made the decision, for example, to mass production, for the mass production of that product. So you see, still you can see track of data analytics here. Another one is ANOVA, or analysis of variance. Analysis of variance is another thing. It's again the same thing, some sort of hypothesis testing, but here we have more than 3 or more items to test the things about them, a hypothesis about them, for example, about their average, for example, about their standard deviation, or like that. That's the reason I'm telling you statistics is mostly know about hypotheses. You remember, we in visualization we learn also about box plot, and we checked something, as far as I remember, it was about MPG and cylinders of a car, that you can check it for different cars, and so the decision making would be easier to decide if there is significant, a statistically significant difference between averages or not. So here we read it together. So ANOVA, that is known with ANOVA, is analysis of variance. Statisticians working, for example, in agriculture setting often use ANOVA models to determine if there is a statistically significant difference in crop yield between 3 or more types of fertilizer. So again, you see here we have hypothesis. What is the hypothesis? Hypothesis is that, for example, there is no significant difference in crop yield between, for example, 5 fertilizer that we have, and they do some statistical processes, all based on data, and to decide if the hypothesis is approved or not approved. Again, you see, there is no decision making about business or anything over there. It's just science, a field related to math, to scientifically decide on something. For example, a statistician may apply 3 different fertilizers to different fields for 1 month and then collect data to measure the mean crop yield. Again, you see the first things that we learn here together: collecting, analyzing, and interpreting. So here, a statistician decide about why 1 month, why into 3 fields, and all the details of that experiment they are doing are designed by statisticians. Is it something that only statisticians can do? No, of course. You as a data analytician, absolutely I recommend you learn statistics as much as possible. When you are taking, for example, your elective courses, if you are interested, go for statistics. Learn softwares that help you with the statistics. One of the good points about our programming language is it is extremely powerful about a statistical analysis that you see is a strong and reliable tool at the hand of data analyticians. So these things that we are doing now together absolutely are not the field that we say that they are absolutely data analytics. They are absolutely statistics that are used by data analytics. And the last thing that I have put here for you that is related to the previous one is confidence intervals. That is something that, again, in the field of statisticians, and in the previous one, you remember, for example, we said that we want them to be a statistically significant difference. And a statistically significant difference, it always comes with the reliability. For example, they said that the significance of this result is 95%, 90%, 80%. So you see, in a statistical analysis, since they all are based, not all, mostly, based on sample. You have a population, you want to come up with some inferences about that population, but population is big, so you cannot check all the items in the population. So you take a sample out of that. So when your decision is based on sample instead of the population, certainty is lost. The result is not for 100%. So the intervals comes to the story. On one side, we see, for example, we said that the reliability of this result is 95%, 90%. And the other thing is that it says, they give you an interval, and it says that, for example, as you can see here, it says that the mean that you are searching for 90% is between this and this. It's a very classic example because it's a normal distribution that you have heard about it in general probability and statistic classes that you have passed. So it says, you see here we have a confidence interval. Here it says for 95%, what you are trying to find is in this range between minus 1.96 and 1.96. That talks about standard normal. And like this. So that interval is this. You cannot say for sure what you are searching for is, for example, 55. But you can say what you are searching for with 95% is between 45 and 55. All these things are in the field of statistics. As you can see, statisticians working in, for example, medical setting often use confidence interval to quantify the mean value of different biometrics. And you see, all the 3 examples that I'm offering you are in different fields. That shows that statistics, like data analytics, is not restricted to one specific area of expertise. Any field that can provide you with data can be handled with statistics and data analytics.